All right, so today we're going to be talking about JWT attacks. This is a pretty long one, or it should be because of how much lab stuff I want to go through, but without any further, wasting time, let's just jump into it. So, what is a JWT? These are JSON Web Tokens. These are basically a standardized way for you to send some kind of signed JSON data between two different systems. The reason you might want to try and sign something is, that you'd want to determine if the token being sent by one application was actually sent by that application or that certain server. So these are typically comprised of three parts, which is a header, a payload, and a signature. For learning about this or really analyzing them in general, if you don't want to use like a burp suite out of the box, you could use this website JWT.io that generated this screenshots and other ones that we'll look at. And basically, it just allows you to look at these things. So the header and the payload are typically base64 URL encoded JSON objects, and the header will contain information about the token itself, in this case a KID and the algorithm. And I believe the algorithm is the only mandatory header. And the payload contains what we call a claim about a user in this case. And so basically the header just determines what cryptographic algorithm we're going to be using to sign the token. The payload is just a claim, so something we're, stating as a fact. And then the signature allows the recipient of this token to verify its like authenticity. So typically, the signature is generated by like hashing the header and the payload together, and then usually or sometimes encrypting that resulting hash and then appending it to the end here, so that if you're the recipient, you can just take those two things together, use the agreed upon hashing algorithm, and then use the public key to encrypt this. And then if they both match, then you can be sure that this token, that the header and the payload haven't been tampered with, and you can trust where this token came from. Now, a few things I do want to cover are like, you'll hear throw like words of like JWS, JWE. Those typically refer to JSON Web Signatures and JSON Web Encryption specifications. So those are just like rules about what you can do or how you should verify the signatures. So you might hear those specifications being thrown around, and they're kind of part of the overarching JWT specification, or at least they're very closely interlinked. So you might hear those things together. Let's talk about JWT attacks. So based on that, right, like this, you'll see JWTs used a lot for authentication or authorization stuff, which makes sense because it's being signed from some other application or something like that. And you might be thinking, well, if it just wasn't for that signature, maybe we could just change up the header and the payload and bypass some access controls. And attacking JWTs usually does mean either messing with the header, like the header parameters that are being used, or by messing with the way that the application verifies its signature. So, and flaws like that usually come from some kind of implementation error. So, like a developer might not properly understand the implications of making a certain decision or using a certain function, and might use it. And it might work, but it might not work in a secure fashion. So, those are things to look out for if you're on the developing side of this, or if you're more on like the blue team, like disaster recovery side. So the first thing we'll cover is like flawed signature verification. And there's basically two main categories. So, if your payload contains a claim about a user and the header specifies how it's being hashed, or how the recipient should verify it, kind of, then that basically just spells out what you'll have to do. If, for example, the signature verification is flawed in some way, one example of this might be if the target application accepts unsigned tokens. So this screenshot here is a good example of an unsigned one. You change the alg header to just say none, and there, as you can see, this third part that would otherwise be here that are separated by these period characters, that third part is not there. And if your application isn't configured to deny this, it might just say, okay, that looks good, we'll go ahead and take it. Or if your JWT library is implemented poorly, it might just accept any signature without verifying it. And or you might, your developer might confuse how the verification and decoding methods work, and it might using that might cause problems with the verification logic, and then you might actually just be accepting arbitrary signatures. So that's one thing you might see. The next thing that we'll kind of jump into is the JWT headers. So there's 3 different parameters that we'll talk about at length, which the only mandatory one is the alg header that just specifies the algorithm that's being used. But the other parameters that are optional but you might be able to take advantage of are JWK, which provides an embedded JSON object that represents a key. There's the JKU, which provides a URL where servers can fetch a set of keys. And then there's the KID, which provides an ID that a server could use to get the correct key if there's multiple keys being used, for example. Because these are in the header, all of these are user controllable. And if you can sign these tokens and get it worked around, then the target application might just accept them and you might get it working. So the first thing you might do is, JWKs allow you to embed a JSON object that represents a key. So you might just use that header like this to insert your own key. And then if the server defaults on using your JWK instead, if it doesn't whitelist its keys, it might just use this when it looks for the KID and says, oh, okay, that looks good. And then because these things correspond to your matching key that you signed the token with, it would all check out just fine. The JKU is kind of similar. It specifies a URL that you hold the keys at. So if you're allowed to change that to point to your server and there's no whitelisting going on, then you could just host the malicious key file, which looks pretty similar to what's in JWK here with a few tweaks. But you could just host your own malicious keys file that has a matching KID to the one that you're submitting. And then the server might just use your JKU to verify the integrity of the key, or the integrity of the signature, instead of the actual JKU that might have otherwise been there. Then last but not least is the KID, which servers that use multiple keys to sign different kinds of data, and the header will contain a KID parameter to tell you which key to use when you verify a signature, which makes sense, right? If you have multiple keys, you need a way to distinguish them. The JWS specification, though, doesn't make you use the KID in a certain way, and you can kind of use it for whatever you want. You might see it point to a file like this. It might specify like a file path or something. And if a symmetric algorithm is being used, you can actually point the KID to some predictable file, which in some cases will let you read files of your choice. So, and you would go about doing that by making a symmetric key, leaving the K field blank at first, and then you modify the header of the token so that it points towards some known file. So the KID might be like etc password, and then you would make sure that the K parameter and the KID match, or like the actual KID and the K parameter match. And then you can sign that token with the, if you have the public key for the symmetric algorithm, you can use the public key to sign it. And then if there's not proper parsing defenses built in here, if the parsing logic is weak, then you might be able to read arbitrary files and stuff like that. The next category is algorithm confusion attacks. So there's a little bit of primer we have to cover, and one of them is just symmetric versus asymmetric algorithms, or like PKI stuff. So symmetric algorithms, basically you use a secret, and that secret can be used to encode or decode, or you could say encrypt or decrypt a message. Asymmetric cryptography is just you have one key that encrypts and one key that decrypts. So you give everyone the encryption key so they can all send you a message, but you're the only one who has the decryption key. So you have a public key and a private key. You know, it makes sense. I'd recommend reading about cryptography just because it's really cool. And, you know, it's like fun to mess around with. You're like the guy who knows about crypto and not the weird crypto. I'll stop talking about other stuff though. Anyway, the attacks of this category hinge on whether or not you can manipulate this algorithm header. So, and the reason this works sometimes is, first, if the logic in place, sometimes it'll have like a verify function that for RSA would take in the like JWT token and the public key. And the, you know, that might work fine for a verify function if it's only used for asymmetric keys. But if you use a symmetric algorithm like HS256, the public key will be treated like an HMAC secret. And because that secret is used both ways, you could effectively encrypt your message with the same secret that's used to decrypt it, and you would have no, you know, issue getting that to work. So all you would, you know, the server would use the same public key to verify the signature that you just used to encrypt your message. So that's why you might have an issue. Of course, in order to actually do this, you need a public key that's used to encrypt tokens. You need to turn that into a usable format, make a JWT that where you set the algorithm header to like HS256 like it is in the screenshot. And then you'll use the public key as the secret so that the, you know, when the server gets it, it sees the public key, it sees the token, it doesn't think there's anything wrong with it. And then that's all you really got to worry about. If you don't have a public key that's available, you might be able to derive the key from a pair of JWTs. So if you have multiple, you might be able to use like JWT tool or some other open source alternative that basically just crunches the numbers and tries to get the public key from multiple JWTs. Let's go over an example. So we'll do some algorithm confusion here in the Cybermonday machine, and then we'll come back and talk about prevention. All right, so I've got the Cybermonday machine up and running. I added the first host name to our hosts file, and I think I've already got the second one in there. The first part isn't really relevant to the JWT stuff that we're going to be going over, but basically, if I remember right, there's like an Nginx misconfiguration that let us dump a Git repository, and then by looking at the source code, we can find, I think there's like an is admin parameter that we can use to get admin access. Let's see if I remembered right. Yeah, there we go. So we're able to just include that when we update our account. And then I think might be messing up. Let's look at the changelog maybe. Yeah, there's information about this webhooks API stuff that they're talking about. Yeah, it doesn't really give us anything awesome, but I think if we just go to this like webhooks API page, it shows us a lot of information about the API itself. And this is where we can actually kind of start delving into the JWT stuff. So first, make sure you've got this JWT editor extension, and I'll go ahead and get rid of this. I think that's just left over from something else I was doing. But what this API does is it allows us to create like webhooks that you can then use to trigger like web requests. We're not going to go that far. We're just going to, what's the word? We're just going to try and do some straightforward stuff. The first thing that I'm going to do is, let's try and use, I think it's we'll use auth register to make an account. So let me just go back to our history here. That's a get request. Let me just send that to the repeater again. We're going to change the request method to post, and we're going to do, what was it? Let me zoom in so you can read that. Auth register. I think this needs to be application JSON data. And then I think we can see it just needs a username and a password parameter. So we're just going to say username Gabe. Whoops, jeez. And password good pass. and we'll see. It looks like the registration went fine. So now we'll just try to do the login API, which just takes the same inputs. So we can just do auth login. Okay. And you can see it gives us this access token. Because we have this JWT editor extension for this, we can actually see what it's doing. So it gives us an ID, which is kind of lucrative. Maybe if our ID is set to 1, that could give us some special stuff. You can also see that it's using RS-256, it specifies type, and it tells us our role as user. That's also kind of lucrative. We could probably change our role to admin. Does it say what roles are available? I don't think it does here. But because this is happening, right, and we know that this is on this webhooks API endpoint, we might just try to see if this jwks.json file is available there. You can probably tell by the history that it is. So at the very least, we kind of have the public key that's being used in a sense, just because we're allowed to see this. Ideally, you wouldn't let somebody see this, but the endpoint does need to see it, so it makes sense that it's available sometimes. We can use this like iteration of the public key to try and perform an algorithm confusion attack. So I think this one's kind of weird. So let me see. I think I want to let's make a new RSA key. And I think this is JWK format, so this will work. Let me just copy all this. And I think, yeah, invalid key. So we need to have, I think we need a KID in here. So we'll just do KID Gabe. And then, oh, wait a minute. Nah, RSA SIG, RS-256, our N value. This should be okay. I wonder why it's throwing a fit. Oh, wait a minute. No, that should be correct. Oh, I see what's wrong. Okay, I need to get rid of that stuff. There we go. Yeah, and I think if we don't have that KID, it'll give us problems because it has nothing to use to look this up. And the reason we're using that KID is because, let me see if I can figure out why. They don't use KID in here, but it makes sense that they would, because they're probably looking it up based off of our username and then using that to verify the role or something like that, even though KID is typically somewhere in the header. But that being said, we have that key that we can now use, and we want to modify this X access token so that we can create a webhook. So if I show you first, let me see, where's the API? So we can do webhooks create. Yeah, let's just do webhooks create. I think that's a good example. So if our, I gotta remember how to do this. So we need to have our, I think it's X access token. And then I don't know if this is a bearer or not, or if it's just authorization. Maybe that's all we need to include. And then it's what? Create, or webhooks/create. Let's try that. /create. You can see it gives us an unauthorized error. I also think that our parameters are wrong. What did I do there? Okay. Because we need to have a name, description, and an action here. But either way, I think we can start to kick off the signing. So if we go back to this request, yeah, I think this looks right. So we can change our role from user to admin, and then we have this really convenient attack button that lets us do HMAC key confusion. So it will use the key that we just made. It'll sign it with HS256. That's fine. Press OK. So it creates a new signature, and you can see now when we send it, it's not giving us an unauthorized error. It's telling us, hey, your name is not defined here. So what we did was we found the public key that they use, and then did an HMAC confusion attack where we changed the payload of our token by signing it with that same public key. I mean, that's just how the confusion attacks are supposed to work. I did this manually when I did the CTF of this, and then after I learned how to use this JWT editor extension for Burp Suite, it made my life for these attacks so much easier. I can't recommend this more. It does kind of eat up your RAM, especially if you're running this in a VM, but it's not the end of the world. So just keep that in mind. We'll go ahead and jump back and talk about prevention. All right. As far as prevention goes, you can protect your applications from most of these attacks by following just a handful of high-level steps. So first is try to use up-to-date libraries when you're handling JWTs. Make sure that your developers understand what they're doing and what all the functions mean and what implications for security those decisions actually have. Make sure that you're verifying signatures. Otherwise you're not really doing yourself any kind of service if you're not verifying JWTs, and make sure that your logic is pretty sound, pretty robust. Make sure that you're enforcing pretty strict whitelists for JKU parameters and which public keys are allowed to be used or which keys are being used in general. And then make sure that parsing errors don't lead to like path traversal in the KID header, which is kind of like an edge case, but it's still worth including. So that's all we've got for today. I'll catch you in the next one.